For today's video, we're going to be talking about the properties of the cosine and sine graph. Just as a reminder, the cosine represents the x values of the unit circle, and sine represents the y values on the unit circle. Our graph from yesterday of the cosine function is shown below, and we're going to talk about the basic properties of this function. First and foremost, we're going to take a look at the domain. Remember, domain is all of the x values that could take place on this function. We talked yesterday about how this function could keep going. So if I were to continue this function, for example, if we were to go to 361 degrees, if we were to keep going, then this graph would just keep going like a wave or like a cycle. So the domain keeps going and going all the way to the right and would keep going to the left. So the domain of this function, all of the possible x values, are all real numbers or from negative infinity to positive infinity. Remember, we write all real numbers with the two bar lines and the r. The range for this function is all the possible y values. Notice that the maximum occurs at positive 1 and the minimum occurs at negative 1. And we know from our unit circle that cosine, or the x values, could equal positive 1 or negative 1. So the range of this function is from negative 1 to positive 1 with brackets because they are included. The x-intercepts of this function is where the graph intersects the x-axis. Notice that this happens multiple times. And if this function were to keep going, I would continue to cross the x-axis over and over. Where we cross the x-axis is at the first time is at pi over 2. The next time we cross the x-axis is at 3 pi over 2. If I cross the x-axis again, or when this function crosses the x-axis again, it will be at 5 pi over 2. And then again at 7 pi over 2. There's a pattern with all of these x-intercepts. They happen at every pi over 2 interval, and then it happens at pi over 2, and then 1 pi distance later. So how we write that, the first x-intercept happens at pi over 2, 0. But it happens at every plus pi later. So how we're actually going to write that is pi over 2 plus n pi, 0, where n is an integer. So any real number. So that n represents a real number, so 1 pi, 2 pi, 3 pi, 4 pi, so on and so forth. That's where all of my x-intercepts happen. Now, an integer can also be negative. So if I were to add negative 1 pi, that would be like subtracting a pi. If I subtract pi from pi over 2, that would give me negative pi over 2. And that is still an x-intercept. Sometimes this can be a little confusing, and I will encourage you that we will review this again in pre-calculus. The main x-intercepts we're focusing on for Math 3 would be the first two x-intercepts. That's the one that happens at pi over 2 and 3 pi over 2. As for the y-intercept only happens once. In order for a function to be a function, that means it only crosses the y-axis one time, and that happens at 0, 1. The maximums and minimums are something that occur multiple times. Just like how we have multiple x-intercepts, because this function keeps going and going, we also have multiple maximums and minimums. So let's take a look at our maximums first. The first maximum happens at 0, 1. The next maximum happens at 2 pi, 1. So these maximums are 2 pi apart. If we were to keep going, we would see the next maximum at 4 pi. The next maximum at 6 pi. So our maximums happen at 0 plus 2 pi n, 1. And we have the same notation, or at least a similar notation, to that of the x-intercepts. So we need to indicate where n is an integer. So my maximums happen at every plus 2 pi. N can be an integer, so any real number. So 0 plus 2 pi times 1, 0 plus 2 pi times 2, 0 plus 2 pi times 3, so on and so forth. A similar situation happens with the minimums. Unfortunately, we don't have two minimums on this graph, but they happen just as frequently as the maximums. So our first minimum is at pi, -1. The next minimum will happen 2 pi later. So for my minimums, it'll be pi plus 2 pi n, 0, where n is a integer. There are a lot of similarities between the cosine function and the sine function. For example, they both continue to go in this wave-like pattern. So if my function is going to continue all the way to the left, and it's going to keep going all the way to the right, which means my domain is from -infinity to +infinity, or what we call all real numbers. The range for the sine function is also from 1 to -1. Of course, we don't write it like that. We write it from smallest to largest, and those values are included. We know that sine represents the y values of a ordered pair, and we can go from y values of -1 to +1. Just like my cosine function, there are multiple x-intercepts for the sine function. And they are pi units apart. So for the x-intercept, We'll start at 0 plus pi times n, comma, 0, where n is an integer. Just like with the cosine function, there's only one y-intercept. For the sine function, however, that y-intercept is 0, 0, or the origin. You'll see that this sine function also has repeating maximums and minimums, just like the cosine function. If we were to keep going, we would have maximums at pi over 2, and then again 2 pi later. So the maximums start at pi over 2 and happen again every 2 pi times n later. And of course, the y value for my maximums would be 1. Where n is an integer. We do want to write that every single time because we're introducing a new variable, and we want to make sure we understand what that variable represents. Minimums are very similar to the maximums, except this time the minimums start at, in this particular graph, they start at 3 pi over 2. There's my minimum, starting at 3 pi over 2, and the next minimum, just like my maximums, will happen 2 pi n units later. And the y value of my minimum is, of course, -1, where n is an integer. As we move forward, we're going to have a couple new vocabulary words. The first one is period or periodic, vertical shift, midline, and amplitude. So when we're dealing with periodic, a function that repeats itself in regular intervals is said to be periodic. And the period is the length of that interval. So, for example, there are 3 graphs that you see. They repeat themselves over and over. This first graph goes up, down, little up, little down. And then we start repeating over and over. So for this first graph, we would say that the period is 4. That is the length of one complete cycle, one interval before the function repeats itself. Looking at the second example, this is just a zigzag, very similar to the first. Its period is also 4. Because that is the length of one interval before the function repeats itself, one cycle. The first 2 graphs have numbers on the x-axis. This third graph has radian measures, pi, 2 pi, so on and so forth. And this actually looks more like a sine function. And so one complete cycle will include a hill and a valley of the sine graph, or one up and down wave. Okay, above the axis, below the axis. And so the period for a sine function is 2 pi. That would be the length of one complete cycle, one wave, one interval before it starts repeating, whatever you want to call it. The period of a trigonometric function is found by dividing 2 pi by the b value. We're going to see this again, but period for a function equals 2 pi divided by b. That's very, very, very important. Very. In a little bit, you're going to see where that b value is found as it relates to the function. Next would be vertical shift. When we talk about a vertical shift, which direction are we moving? That's right, vertical is either up or down. And typically when we move a function up or down, that means we've added or subtracted a number at the end of the equation. We know from long time ago, if I had a function y equals x plus 2 quantity squared minus 4, this minus 4 on the backside means I went down 4 units. That same relation happens in trig functions. Whether it's got a sine x, sine theta, cosine x, cosine theta. So if we move our function, if we add or subtract a number at the end of the function, outside of the parentheses, outside of the variable, that means my function is going to move up or down. Now remember, since we're outside of the parentheses, nobody's lying to us. If it's a positive, it's going to be plus something, we're going up. If it's minus something, we're going down. So for this first function, y equals sine x plus 1, we're going up 1 unit. Y equals cosine x minus 2 means we're going down 2 units. We're going to pause for a minute and I'm going to go to Desmos so that we can see the relation between the original graph and this vertical shift. Welcome to Desmos. As you can see in red, I have graphed the parent function y equals sine of x. And then in blue, we have y equals sine of x plus 1. The entire function has moved up 1 unit. I would like to pause for a moment so I can show you a couple of things that I've done. If you go to Desmos.com right now, you are not going to see labels of your x and y axis like I have here. There are a couple things I've done to make this graph look a little neater and in radian measures, so it's a little easier for us to see where things are happening. So I'm going to show you my menu under the wrench, and I would like for you to pause the video and make notes in your notebook about the changes I have made to the window. So, as you can see here, about halfway down where you see the x-axis, notice my x-axis is going from negative pi, which is less than or equal to x, less than or equal to positive 2 pi. Negative 2 pi to positive 2 pi, and my steps are pi over 2. Now, to get that pi, by the way, you just type the letters pi. You spell it out, and it'll pop up the little pi symbol, and Desmos knows what you mean. Also for my y-axis, I've just made it a little shorter so it's not quite as oblong. I just went from -5 to +5, and the step value would automatically be 1. Notice I am still in radians. If you wanted, you could go from -360 degrees to +360 degrees, just changing from radians to degree mode. However, I strongly recommend whenever we are graphing trigonometric functions from here on out, please use radians. Again, when you are graphing trigonometric functions, please use radians. Now, whether my function says sine or cosine, the transformations are still the same. So here's cosine plus 1. I think the example we had before was -2. So there goes my cosine function down 2 units. In this math class, we're simply going to focus on moving up and down. We are not going to focus on moving left and right. That is called a phase shift, and that is required in pre-calculus. So there's a little something for you to look forward to. The next vocabulary word we're going to talk about is midline, which is a horizontal line midway between the function's minimum and maximum value. Because it is a horizontal line, of course, it's going to be y equals some number. And I want to go back to the problem we were just looking at with our cosine function to identify what my midline will be. So here's a screenshot of the y equals cosine x function and y equals cosine x minus 2 function. So for my original parent function, or the cosine function in red, I have a maximum at +1, a minimum at -1. So halfway between is going to be the line y equals 0. That represents my midline. For the blue function, we moved down 2 units, which means everything moved down 2 units, including my maximum, which is at -1, and my minimum, which is now at -3, which means my midline, the line halfway between my maximum and minimum, also moved down 2 units. Which means this midline is at the line y equals -2. Notice that line y equals -2 is equal to my vertical shift. My vertical shift went down 2, which means my midline went down 2. There's a great connection there between the midline and the vertical shift. The last vocabulary word we're going to talk about is amplitude. The amplitude is the distance from the midline to the minimum or the maximum. Now, it does not matter whether you're going to the minimum or the maximum because they're going to be the same, because your midline is in the middle of your minimum and maximum. So this is typically denoted with the letter A. And remember that if A is negative, we reflect the function across the x-axis. This is very similar to a horizontal stretch or compression that we've dealt with before. When a was a positive number greater than 1, my function would get taller. If it was a number between 0 and 1, it would get shorter or closer to the x-axis. And then, of course, if it was negative, it would reflect. Those same properties that we've talked about with transformations of every function can be applied to trigonometric functions. And we're going to use Desmos to get a great visual of amplitude. So I've gone back to y equals cosine x. Here you see the parent function. We can assume that there is an imaginary 1 in front of that cosine, which means my amplitude is 1. The distance between the midline and the highest value is my amplitude. And I need to use a different color. I am so sorry, friends. So the amplitude is the distance from the midline to my maximum. In this case, it's 1 unit. If I were to show you y equals 2 cosine x, I have not moved up or down, so my midline is still the same. But now the distance from my midline to the maximum is 2 units. So my amplitude is 2. I have stretched my function 2 units. This third example says y equals -3 cosine x. So now 2 things have happened. First and foremost, I am 3 units between my midline and my maximum or minimum. But also, instead of the function starting at a positive y value, I have reflected across the x-axis and start at a negative value. So then from the negative value, I go up my hill and then down my valley. Whereas before, in the original function, I started at the top of my hill, went down into my valley, and then up the hill. When you are graphing, there are actually steps to successful graphing. The first step is to determine the period or your length of one cycle and label the graph accordingly. The second step is to sketch a basic sine or cosine graph. And we always want to start with that basic graph, like I showed you on Desmos in red. We want to start with that basic graph to give us an idea of where we're starting and where the points are going to move to. As we saw in the last example, it's very important to start with your amplitude. We want to see how we need to stretch the graph before we move it left, right, up, or down. Keeping in mind that step 4 If your A is negative, we need to reflect across the x-axis. Step 5 is, of course, the vertical shift, moving up or down. And then we'll get into what's called a phase shift, and that's where we move left or right. And we'll do that in pre-calculus. Now, where are all these letters coming from? This is a completed equation with all of the letters we have discussed. Y equals A cosine B parentheses x plus or minus c close parentheses plus d. The A in the front represents my amplitude. The B helps me determine my period. There we see the period equals 2 pi over b. We're seeing it again, so it must be important. C is my vertical shift or my phase shift. And again, we'll do that in pre-calculus. And then D, outside of the parenthesis, that's my horizontal shift or my up and down. Now, just so you know, you may see it like this. One of the main differences is we're using lowercase letters instead of uppercase letters, which does not really matter. A second difference you might see is we have sine instead of cosine. Again, you can replace sine with any of the 6 trigonometric functions. We can do this with sine, cosine, tangent, cosecant, secant, or cotangent. The big difference is where the B is located. Notice here, the B is inside the parentheses instead of outside the parentheses. That is going to be a big game changer when it comes to our horizontal shift, which is what we'll do in our next math class. But I do want to go ahead and bring it to your attention. Now, I do want to make sure we know amplitude is the A, change in period is the B, 2 pi over B, 2 pi over B. The horizontal shift is going to be with our C value. Don't forget, your X lies. It's inside the parentheses, so he is lying. And then last but not least, the vertical shift is the outside value. This is where we're going to end our lesson for today. There are no practice problems for today. I need you to take detailed notes from this PowerPoint and make sure you ask any questions you may have about the concepts we have discussed today. Amplitude, midline, vertical shift, and period. How to find them in an equation and how to potentially graph them. We will have plenty of practice problems on Wednesday. I hope you have a great day.